Next, we talk about how to solve technical contradiction. Okay. Before that, we have to understand technical systems. Commonly, they have several engineering parameters such as size, weight, color, something like that. Okay, when the problem happens, identify the suitable engineering parameter can help us to solve this problem. Okay, so actually, Asura they analyze the pattern database and they summarize 39, the engineering parameters. Okay, so TRIZ use 40 inventive principles to address the technical contradictions. This contradiction matrix is a 39 by 39 matrix. Okay, so in this matrix, one parameter is improved when the other one's getting worse. Okay. So this is the procedure of using contradiction matrix. Okay, usually we can have the problems and we identify these problems, the parameter, two parameter, one getting worse and one getting better, and which one. Okay, in identify the two parameters in 39 engineering problems, okay, parameters. So according to the 99 by 39 by 39 matrix, we can find the mappings 40 principles. Okay, just as you see, the attached file in iSchools, I provide you a PDF files. They can including the 39 parameters and the 14 inventive the principles. Okay, that's the contradiction matrix. Okay, this is mean the parameter getting worse. This is getting better. Okay, so for example, the parameter 1 have getting worse. We want to the parameter 3 getting better. So the principle of the inventive is A 15, 29, and 34. So we can go back to 8. 8 is here. Counterweight 35 is dynamic. Okay. So we have some principle can help us to solve this constraint. Okay. Okay, so we use the very simple examples, to open an envelope. If we open a letter directly by feel it, okay, the advantage is quick, but it will destroy damage, our letters, okay, and the envelope edge look ugly. Okay, so if we have tools, we use tools, something like the letter opener. Okay, the advantage is we can have a mid edge and no damage to our letters. Okay, but the weakness is is inconvenience and it takes some time. Okay, it's a little slow. So we want to design open a new way to open envelope both quickly and reliable. But speed and reliable is contradictionary. Okay, so speed getting better, the the reliability will getting worse is a technical the contradiction. Okay, so in this case, the uh, the parameter we don't want to getting worse is loss of time, and the parameter we have to improve is reliability. So according to the contradiction matrix, okay, so we can suggest, okay, in inventive principle 10, number 10, number 30, and the number 4. Their meaning are as follow. Okay, number 10, principle 10, that's pretty memory action. Okay, and the principle 30 is flexible, membranes or thin film. Okay, and the principle 4 is symmetric. Okay, so actually we applied principle 10 and the principle 30. So principle 10, according to the principle 10, we suggest adding auxiliary object in advance. Okay, and the 13 principle 30 suggests using the flexible straight or tier line. Okay, tier line. Okay, so combine these ideas, we can add a tier straight or tier straight to the envelope to make it easy to open. Okay, besides principle 10 also encourage making a partial pre-change to the object, so we can punch a small hole along the seal to make teal even easier. Okay, so okay, that's small. This is another example using the contradiction matrix. If we want to make laptop PC lighter, that means not too heavy, so we can easy to carry. Okay, the laptop notebook PC. Okay, but if we reduce the weight, the strength, and the durability of the case decrease. Okay, so the contradiction, we got to identify the parameter improve and the getting worse parameters. So we have to make the weight of moving object better, and we have to keep the strength getting worse. Okay, so step 1, we have to identify parameters. So after analyze these problems, the parameters should be parameter 2, that's improving weight. Okay, improving parameter, and worsen, getting worse is strength. Okay, so according to the matrix, we suggest principle 1, 35, and 40. Okay, and the step 2, we applied this principle to have some ideas. So according to the principle 1 is segmentation. So we according to this principle, we use a major design. We make the laptop body from several lightweight and strong panels instead of one solid piece. Okay, and principle 35 is parameter change. We change in the material. Okay, we use carbon fiber or something lighter. Okay, so we can consider both light and strong. Okay, and the principle 40 composite materials, we use the other stronger but lighter materials to make sure to solve our problem. Okay. In this part, we will introduce using TRIZ to create a new function. An example of the online games. Actually, the source is the come from this journal paper. So if you are interested, you can find the journal paper and read it. Okay. Okay. Actually, we use the Kano models to develop a theory of the attractive quality. Okay, so as we know, Kano models is to categorize the customer's certification. So according to they can divide it into the customer's certification into several category. Okay, they are attractive quality, one-dimensional quality, indifferent quality, and the must-be quality. Okay, attractive if the even we don't have such kinds functions, the user's customer don't feel at this point. If we have just a little, they are very, very happy. There's attractive element. One dimension is the functions getting more, they feel the good. Okay, so it's a linear relations. Indifference, no matter the functions is or not fulfill or not, their certification is no different. Must be if we have, they don't feel unhappy. If they don't have, we are feel disappointed. So usually they have several successful applications, and in Kano models, how to there are life cycles between these elements. So how to create attractive quality is a very, very important issues. Okay, it's not only can bring must be products back to attractive products, it also can discover the latent customer need. So in practice, maybe we have some embarrassing situations. Maybe poor decide questionnaire or poor defined quality attributes. From these problems, maybe we cannot find attractive quality. Okay, so objective of this study is, proposed TRIZ Kano models. It can help us to create a new function of online games. Okay, so TRIZ, we will skip this part because this we already talked first. Okay. Okay, next we will introduce the proposed TRIZ Kano model. Okay, actually, they have the 6 steps. Step 1 to step 3 is doing the Kano analysis. Okay, if the Kano analysis we don't find any attractive quality, so we go to TRIZ to create to go to the phase of objective quality creations and do a kernel analysis again, and then make a conclusion. Okay, this is the step of the attractive quality creation. Use the TRIZ. So we define a problem, we analyze problem with selected parameters. Okay, something the getting worse, and something help to improve. Okay, according to identify two parameters, we can use the contradiction matrix to find some candidate inventive principle. Okay, and according to these principles, in step 5, we can develop a new available solution. Okay, so we take the gain picture, for example. Okay, so gain picture can be defined as gain pictures are smooth of high definitions unique. Okay, so then we come to a question kernel style questionnaires. Okay, that they are fulfilled, not fulfilled. So after survey, we can know most of the responder, they consider this gain picture is indifferent. No matter is have or not, they don't change the certification. So so we go to the use TRIZ to create a new function. Okay, so we define a problem how display gain picture more realistically in a limit space. Okay, so we analyze these problems and identify the parameters getting worse, and we have to improve. Okay, so according to the contradiction matrix, we can find 3 principles. Okay, and according to these principles, we can define some solutions, and we go back to do kernel analysis. So that's our new ideas. We use the HUV to display pictures realistically. Okay, so we redesign kernel style questionnaires and survey again. Right now, we can find the quality clarification should be attractive. Okay, so that can confirm our method is effective. Okay, so actually we have 15 quality elements, and this is before, this is after. So we can know after introducing TRIZ kernel models, we can create some new quality attributes. They are considered as attractive. Okay. This is another case study. In this case study, we use TRIZ to create new RFID functions. Okay, actually, it's come from as persistent with application. Also, my papers